This is a video for number 1 through 12 on your test review. And number 1 through 12 is no calculator allowed. So we're just talking about whether something's a function or not, even, odd, 1 to 1, and the parent functions. So number 1 is a table of values. So first, to determine whether or not you're a function, you look at the x column. Remember, the definition of a function says that every x has only one y value associated with it. One way we can kind of streamline that process to determine if you're a function is look at the x's and see if any of them repeat. And in this table, none of the x's repeat, which means none of the x's have more than one y value. So yes, that is a function. For our table, to determine if you're 1 to 1, we then looked the other way at the y values, because none of the y values can repeat. All the x's and all the y's have to be unique in order to be 1 to 1. Now, when I look at the y column, I see that the 11s show up more than once. That means that y value is not unique, so this is not a 1 to 1 function. And the question is this even, odd, or neither? Well, you could graph this if you wanted, plot the points. Here, if we just look at negative 211 would be up here, 0, 7, 211, 423, and 643. That is definitely not even, odd, or neither. Or that's not even or odd, so it would be neither. Number 2, is it a function? Well, it's a graph, so we use the vertical line test. This graph fails the vertical line test, so it's not a function. Because this is not a function, it is not 1 to 1. Even though it passes the horizontal line test, you can't be 1 to 1 unless you're already a function. And this graph is also neither even or odd because it's not symmetric over the y-axis or the origin. Number 3, is a function. It passes the vertical line test. Remember, there is an asymptote on the y-axis, so we are not failing the vertical line test there. Same with 1 to 1, it is 1 to 1 because there is that asymptote at the x-axis, so we're not actually touching or crossing the x-axis. Even, odd, or neither, this would be an odd function because the graph is symmetric over the origin. Number 4, having equations. We have to think a little bit carefully about the exponents. First of all, is this a function? Well, think about what you know about parent functions. The x squared means you're a parabola. So this is going to be a parabola that looks something like this. It is going to be a function because it would pass the vertical line test. Is that parabola 1 to 1? No, because it would fail the horizontal line test. And even, odd, or neither. Well, you can think about the graph, but if you're not sure what the graph looks like, think about the exponents. Remember, even functions have all even exponents. Here I have an exponent of 2, and remember the constant has an exponent of 0, which they consider to be even here. Since every term has an even exponent, this would be an even function. Number 5, is this a function? Yes, it passes the vertical line test. It also passes the horizontal line test, so it is 1 to 1. Even, odd, or neither? Well, this graph is neither because it does not reflect over the y-axis or the origin. Number 6, parabola is a function. It fails the horizontal line test, so it's not 1 to 1. And this graph would be even because it is symmetric over the y-axis. A couple more here. We're going to look at some equations. Number 7, is this a function? Well, 7x cubed plus 1 is a function. This is very similar to your parent function here of x cubed. So it is a function, and it is 1 to 1. Is this even, odd, or neither? Well, look at the exponents. My first exponent is odd, but 1, the constant, again, has the exponent of 0. If I have an odd and an even exponent, you are neither even or odd. And finally, y equals x to the 5th. You don't know this graph, you know x to the 3rd, but we have talked about how x to the 5th is the same parent function that's flatter right around the origin. Yes, x to the 5th is a function. It is 1 to 1, and the only exponent here is odd, so this would be an odd function. All right, 10, we are writing parent functions for each of the graphs. So you have to dig into your brain and remember which one is which. This one here, this was one for A that got confused a lot with the square root function. That's actually your log of x function. Remember, that's one that I'm not going to make you graph, but you should be able to recognize it. This graph we use a lot this unit. That is y equals x, or f of x equals x. That's your parent linear function. Next one here, if I have a point at 1, 1, and then 2, 8, that would be x to the third. This graph, I have a point at 0, 1, and 1, 10. That's an exponential function, and that is 10 to the x. This guy here, points are 0, 0, 1, 1, 4, 2, 9, 3. Well, that's the square root of x. That's your square root function. Think about the ordered pairs. The square root for this point, if I have 0.93, the square root of 9 is 3. This is your absolute value of x, your absolute value parent function. And these last two look very similar, but remember we look at the base, right? They both have the point 0, 0, 1, 1, and negative 1, 1. But you look at the bottom. Now this graph on the left has a flatter base, so that is x to the fourth. Remember that kind of parabola shape, the higher the exponent, x to the fourth, x to the sixth, the flatter bottom gets. And here would be your basic quadratic function, x squared. All right, two more. Multiple choice. What's true about this graph? So this graph, first of all, when I look at a circle, it's definitely not a function. So I can, before I even read through things, eliminate a and b. C says it's not a function because there are multiple x values for a given y. Okay. And D says it's not a function because there are multiple y values for a given x. Think about the definition of a function. The definition of a function says every x has only one y value. So which definition, C or D, matches that? Well, that would be D. There is more than one y value. So if I picture this x right here, there's more than one y value for that given x. That's actually kind of the definition of the vertical line test. So that graph fails the vertical line test because of that rule. All right, number 12, which is graphing parent functions. Remember, we want to be precise for each of these graphs. So plot as many points as you can fit on the grid. X squared. So if I start at 0, 0, if you need to, make a table of x and y values over here to help you plot some points. You should know the basic parent function for x squared. If I go out to 1, 1 squared is 1, 2 squared is 4, 3 squared is 9. And then that graph reflects over I graphed that wrong, reflects over the y-axis. So there's your basic x squared, not as pointy as mine. Is that graph 1 to 1? No, but it is an even function. It reflects over the y-axis. Y equals x, you should be really good at graphing here. That is your basic linear function, slope of 1, y-intercept at the origin. So that would be y equals x. That is 1 to 1, and it is an odd function. It reflects over the origin. Opposite quadrants are the same. C, the square root of x. Right, so you start at 0. The square root of 0 is 0. You know you can't go to the left. You can't have negatives because we can't take the square root of negative 1 and graph it. So we don't worry about that. The square root of 1 is 1. Square root of 2 and 3 are irrational. The square root of 4 is 2. And we're irrational until I get to the square root of 9, which is 3. So that would be your square root graph. That is 1 to 1, but it is not even or odd because it's not symmetric over the y-axis origin. X to the fourth. Think about your table here. 0 to the fourth would be 0. 1 to the fourth is 1. 2 to the fourth is 16. And then we would reflect. So I have 0, 0, 1, 1. And 216 doesn't fit on my grid, but it'd be way up here. And then I reflect on the other side. And again, I'd be way up there. So when I make this graph, I know that I'm going to come down. It's going to be a really narrow kind of parabola. But remember, I'm going to try to graph it so it's a little bit flatter at the bottom than x squared. Okay, just try your best. Is this 1 to 1? No, but it is an even function. X to the third. Some of us had some trouble with this one originally. If you need to, make a table again. 0 to the third is 0. 1 to the third is 1. And 2 to the third is 8. So I plot the point 2, 8. And then I actually reflect the other way. Negative 1 cubed is negative 1, and negative 2 cubed is negative 8. So this graph kind of squiggles through the axis and all the way up. But you need to have 2 to the 8th plotted. It's not 6. 2 to the third is not 6. Some of us make a little bit of a mistake there. 1 to 1, yes, and this is an odd function. All right, the absolute value of x. Start at 0. Now remember, the absolute value graph, I take the absolute value of 1, it's 1. It's basically the y equals x graph, except I don't go into the third quadrant. I bounce back up into quadrant 2, because when I take the absolute value of, like, negative 3, I get a positive 3. I reflect back up into the positive y quadrant here. So it's your absolute value graph. It's not 1 to 1, but it is even. And I think that's all of them. Yep. So that's all the no calculator stuff. You should also be able to do, just look at a graph, find all those max, mins, intervals of increase and decrease without a calculator as well. But that's the main portion without a calculator.